Okay, so today we are going to graph this function by rewriting g of x, and we're going to rewrite it so that it's in this form. So the same form that we did yesterday, so that we can identify h and k and go back to graphing it just like we did yesterday. So the idea is to turn it into a problem we did yesterday. The way we are going to do that is fraction means division. I'm going to divide the numerator by the denominator. You can use long division, you can use synthetic division. It's up to you. Some problems will be easier with synthetic, some will be easier with long division. This one is going to be easier with synthetic, so I'm going to use synthetic division. So let's see here. Bring down the 3. Negative 1 times 3 is negative 3. Add 5 plus negative 3, that's 2. So remember the way this works. This is our remainder, this is our constant. So our new function, I'm just going to write it to the right of it, just for space reasons, is going to be 3 plus 2 over our divisor. If you notice, if I rearrange this a little bit, a slight rearrangement, this is now back to the type of problems we did yesterday. And that means I can go through and graph it just like we did yesterday. So I've got our vertical asymptotes at -1, our horizontal asymptotes at 3. So I think this coordinate grid should work out well for me. So let's see here. Vertical asymptote at -1, horizontal asymptote at 3, 1, 2, 3. Now remember, the key here is we're now going to graph a similar function with this being 0, 0. We're going to graph a similar function. That similar function, because we dealt already with the translations, this and this are gone. So I'm going to graph y equals 2 over x right here with this being 0, 0. So just like we've been doing in the past, I'm going to use my parent function, which is y equals 1 over x, and then I'm going to stretch it. So this is x, this is the y for the parent function, and then I'm going to take 2 and multiply it to y to deal with that vertical stretch. So in this case, using our typical numbers, I'm going to use -2, -1, 1, and 2. And again, if I'm plugging them into 1 over x, then I get -1/2, -1, 1, 1/2. If I then stretch all those y values by 2, I get -1, -2, 2, 1. So graphing this, when we are finished, I've got the point -2, -1. Remember, we're treating this like the origin. -1, -2. So that graph hugs the horizontal asymptote, passes through, hugs the vertical asymptote. Then on the right-hand side, same idea. I've got the point 1, 2 and the point 2, 1. That's going to hug our horizontal asymptote, hug our vertical asymptote. So again, big idea. We can graph this function if we want. Another way of graphing it is by rewriting it into that form and then using what we did the other day in order to graph.